Hello, everyone, and welcome to episode 7 of our series called Software Package Deconstruction, How to Assess Risks to Your Software Supply Chain. Each episode, we deconstruct a software package and do a deep dive into its risk profile to better understand its unique attack vector. And we hope that in some small way, we can enable your security team to stay one step ahead of malicious actors. Next slide. Let's start with a little bit of housekeeping. If you have any questions or comments, please submit them through the Q&A feature on Zoom webinar. We are recording this episode for those who can't attend live, and you'll be able to find it on our website's media pages shortly after the conclusion of today's webinar. After the webinar, we'll also be sending out a follow-up email to all registrants with any relevant links we think you might find useful, as well as a link to the aforementioned recording. And finally, if you like subtitles, click the live transcript button to enable Zoom's closed captioning feature. Next slide, please. Well, who is ReversingLabs, you may be asking? Protecting organizations from increasingly sophisticated cyber threats is what we do. At ReversingLabs, we leverage the world's largest threat intelligence repository to protect software development and power advanced security solutions. Our threat intelligence repository is 7 times bigger than VirusTotals, and it keeps the most advanced cybersecurity organizations and Fortune 500 enterprises informed and in front of malicious actors. Our software supply chain security, and threat intelligence solutions have become essential tools for advancing enterprise cybersecurity maturity globally. ReversingLabs operations are spread throughout the US and Europe, with offices in Zagreb, Croatia, and Cambridge, Massachusetts. And our customers are in just about every corner of the globe. We've got just under 300 employees, and we're looking to hire more. So if you or someone you know is in the market for a new opportunity, please check out our careers page to view our current openings. Next slide. The man who will be deconstructing these software packages for you is Tim Stahl, a seasoned security professional who boasts almost 20 years of experience in information security, with additional experience in information technology related to both the engineering and administration of enterprise networks. Tim has secured and defended networks across .mil, .gov, and .com enterprise domains, and his expertise includes the tracking of both APT and criminal groups, threat intelligence, threat hunting, data analysis, OSINT research, DevOps, and SIM engineering. Next slide. The subject of today's software package deconstruction is fine-tuning your baseline code signing certificates. This is a continuation of the last session on creating and tuning a baseline for software supply chain analysis. But in this session, we're going to focus on code signing certificates, the role they play in software, and the many ways they can be abused. And if you understand these elements, it'll help us define and tune our baselines in that area. So in this episode, we will explain the purpose of code signing certificates, how they function, and how they can be used to detect tampering. We'll cover topics like certificate authorities, certificate validation and revocation, and how weak certificates can provide a false sense of security. Next slide. The tool that we'll be using to discuss code signing certificates is the Software Supply Chain Security Platform from ReversingLabs. The SSCS platform decomposes the final deployment software image, describes its underlying software behaviors to determine deployment risks, and when it finds a red flag, it prioritizes remediation guidance. SSCS is powered by the world's largest private file reputation repository with over 10 billion files and about 4.5 million new files added daily. It not only helps prevent threats from reaching production, but can also find exposed secrets before release. And as a bonus, it can also generate a complete SBOM. And with that, let's turn it over to Tim to begin his deconstruction.
Welcome, everyone. Like Guy said, we're going to talk about code signing certificates, but we're going to discuss it as part of your risk assessment, right? When you're doing this kind of stuff, when you're doing TPRM or you're looking at purchasing software, anything like that, it's all about assessing the risk. What we have now, what we've done in the past has mostly been based on, malware and CVEs, because that's the extent of the visibility we had into software. It was a closed source. You had to sort of pay attention to what it did when it was on the network, or you could test it in a sandbox and see. But that doesn't really work well with software. Dynamic analysis isn't great. It's good for malware and it's built for malware, but it's not really great for software, where software requires human interaction. There are different configurations. You can add plugins and different things. So it'll act differently depending on how it's being used and which user is using it. So now that the tools are catching up, this is opening up a whole new branch of security. This type of analysis is different than anything we've done before. It's an extension of what we've done as part of this risk assessment kind of thing, but you were always looking at outside external information. Now we have the ability to crack these packages open, see what's inside, look at the behaviors, look at all the things they can do on the network, what protocols they use, all of these different things. So all this new data can help inform your risk assessment and let you do a legitimately valid risk assessment. So code signing certificates are a familiar object. This is something we've all heard about. We've all seen, we see certificates every day in our browsers and everything else. All of these things are built as a form of trust. All right, it's a validation that the person, whoever it is issuing the software, is who they say they are. It's a third party validating that this certificate was issued to this company. So they can, when you see these certs, when you do this package analysis and you crack open a package in a tool like ours or another one, right, you get information that you can use, but you have to look at these things differently. The information that you have and the state that these certificates can be in gives you different insights into not only the package, but the vendor itself, how they produce their software, what their pipeline looks like, what tools and visibility they have into their stuff, and how much of their tech debt are they passing on to you because they don't want to spend time fixing these security issues or updating their stuff. So that should be part of your risk assessment. You're looking at the package itself, but also the vendor. And now you have the insight to do that. So we'll talk about how you can do that with code signer certificates based on these issues that we see a lot in other different packages doing our analysis over time and helping our customers. So a certificate can have multiple states, right? What we're mostly seeing, and you've seen these before, is valid certificates. It's working as it should. There's a certificate authority that work with someone who got the certificate to prove, yes, this is Microsoft. Microsoft asked for the certificate. We issued it to Microsoft. You can trust that. And then that chain is longer and longer. There's multiple steps in those chains, but it's all about trust. Some certificate authority has issued this cert to Microsoft. Microsoft then uses it for a certain team or a certain product, and then they can create certificates based on this. So it's this long chain of trust, and you're looking for unbroken chains of trust, which means it's a valid certificate. It's only good for a certain amount of time. Is it within that time range? They expire to avoid any issues of abuse, the same way your credit cards expire every 2 or 3 years. Someone gets that, it limits the damage they can do. And we'll talk about some other ways that happens and some other mitigations that can be built into the code as we go. So as you can see here, there's a handful of different states your certificates can be in. Self-signed is similar to a regular cert, but it would be Microsoft creating a cert and signing it themselves. So it's I am who I say I am because I said so. Depending on the source, it's less trust than a normal certificate that's given by a third party. There's no validation there. You just have to trust the vendor then. Still not bad. You don't see them a ton, but there are cases where they're valid. So you may see them from time to time. We don't really see a ton of that except for big vendors like Microsoft, Oracle, that kind of things. They would be the ones who would tend to do this. But again, it doesn't happen all that frequently from my experience. Malformed is another one, right? That's where we sort of get into, the issues you need to be aware of. And then as we go through expired, untrusted, and signed while expired, right? Those are things where you now have a higher level of risk, and then invalid and revoked are the serious issues that you need to be aware of. So we'll talk about those a little bit, but there's a lot of documentation online. You can look these things up. I'll recommend DigiCert. That's a partner of ours. They're really good, but they also have a lot of really good information, really concise information on their website, a lot of how-to and explanations of stuff. So I definitely recommend them as a resource. So expired certificates is the first thing. And you do see this a lot with code signing certificates, especially in packages. You would expect to see a handful of these in almost every package you touch. There's going to be a lot of these where they're expired between 1 and 3 years old. And if your tool gives you a lot of details, you'll see also the other certs in there and how long they have to go. So you'll see things that are going to expire in a few months. There's always a time limit, especially for code signing certs. And it usually tends to be 18 months to 2 years. They can be longer, but that's just a higher level of risk, right? Because if someone abuses that, then it's valid for a longer time until somebody catches it. So you think about this as the component was signed by a certificate before that cert expired. So however old that certificate is and whenever that expired, if it expired 2 years ago, then that element was built and signed probably at least a year before that. So it gives you a sense of how old the components are in your package, right? And how much care and craftsmanship goes into making this, right? Again, it's a little bit about the vendor itself. Are they monitoring these things? We see this a lot in third-party applications. Third-party components that a vendor uses as part of their software so they don't have to rebuild these things. But are they going back and checking? Are they making updates to these things? What you see here in this chart is what we see once they get a few years old, you'll start to see CVEs pile up, right? 2 or 3 years old is where you start to see this. These things this is a state in time. It was built 3 years ago based on the best practices 3 years ago, or 8 years ago, or 12 years ago. It's not uncommon to see components that are 20 years old. They generally tend to be tied to Microsoft because who else has been making software that long? But still, these old things are a snapshot in time. They're built based on the best practices at the time. And those can introduce a lot of issues. There are a lot of, best practices evolve. There's always new mitigations coming out, new ways to protect your code. But these old elements won't have that. And sometimes it's just as simple as going and updating that third-party package, right? They also collect a lot of CVEs, and mitigations are the main things, but these sort of files rot over time. And usually as a vendor, once they're put in and they're going, producers are so focused on new content, new features, and driving new sales that some of the stuff gets pushed off to the side. And if it doesn't break and there's no complaints about it, they don't touch them. So it gives you a sense of, what the focus is on that vendor and how much you can trust them. So these are the little things you can look into and see. When you start getting older and older, 8 years out or older, around that time frame, you have to start worrying about some of these standards that were used to build these pieces of software, like cryptography. Anything that's dealing with network communications and secure communications, if those components age out, there are old standards of cryptography that are no good anymore because computers get faster and faster and you can crack these things quicker and quicker. So if you're using old implementations, they may have older standards like this that could be even a bigger problem. These are all things you have to assess as part of your risk. It's that attention to detail, right? Is you're assessing this package, but also where is it coming from? And another way you can do that is you can look at different packages from the same vendor. If you're looking to make a purchase, try and run 2 or 3 different lines of software from them. That'll give you a sense of, do these problems propagate across all of this company's stuff or just this one piece of software? It's, again, another way to evaluate a vendor that we never had before. Untrusted certificates are a little bit different. You really don't see this very often. If you should, I would check with the vendor, try and find out what happened. But you can usually trace the certificate. There's places you can look these up and find the chain of trust. We have tools that do that. But it's a valid cert issued by a certificate authority that isn't in your list of trusted certs. So we're going to trust this many things. And you see this a lot with browsers where they'll just randomly untrust a certificate authority. And that means, in that web browser, nothing tied to that will be trusted. You won't be able to get to those sites, which is the point, right? It's all about trust. And this is somebody saying you can't trust this authority. There are a lot of them out there, a lot of weird ones out there. And you generally built in there's some standard to say, hey, these are the trusted list of authorities. If that's not on your list, if not part of the integration or part in, the list of trusted CAs in your browser, which is updated by the vendors all the time, Google or whoever. If it's not on there, then it's an untrusted certificate. It's definitely worth looking into. When it's, like I said, if it's the vendor's code and they're using a certificate authority that isn't broadly trusted, that should be an issue. That's something you want to go back to the vendor. find out why they're doing this, what it is, especially if you're doing this software you own and you're scanning every update, every new issue, every new major update to the package, whatever. If you see it all of a sudden pop up, definitely is something that you want to stop, get an answer for, or keep escalating until you get a good answer, right? Shouldn't happen very often. When it does, I'd be concerned about it. But again, it's usually generally broken trust somewhere. Signed while expired. We do see this occasionally, not a ton, and you really shouldn't see this. Again, this goes back to the vendor itself and the care that they're taking. Once a cert expires, you should get a new one. That's the whole point of these things. You shouldn't be using them unexpired. So if you see a vendor signing elements with a certificate that has already expired, that means they're not even paying attention to their own stuff. So if they aren't watching their own, the pieces that are supposed to build trust in you, so you can trust this software, if they're not taking care of that, then how much other things are missing, right? What else are they skipping on? What else aren't they spending resources on? I'd question the security of the software and the vendor itself if you see these things. Again, if it pops up once, sure, maybe it's an accident. But I would want to see it corrected immediately. I would still alert the thing. I would alert the vendor, ask them what's going on. But if they fix it again, fine. It happens. Nothing is perfect. But if you see it more than once or they don't correct these issues, that should figure into your risk assessment for, again, the package you're scanning, but also the vendor. Invalid certificates is where you start to see issues. This is where you really want to be concerned. It means it's a legitimate certificate, right? There's no issues with the chain of trust, all the things that make this valid, right? So the trust goes all the way down, but it fails because the hash is mismatched. So part of the validation for a certificate is saying, this is coming from somebody who, you can trust that this is from Microsoft or whoever, right? But it's also to say this hasn't been tampered with. We hash that. When you sign it, it gets hashed, and that means you can't change one bit. You go into that code and you put a space in it, the hash will be different. So when you see these, you have to view it as a sign of tampering. There's a lot of depth to these things, the certificates and how they work and how the trust is, all the things that go into this. There's so many details and there's so many weird corner cases, other reasons that maybe this could happen. There are actually some legitimate reasons that people will insert extra information, producers will insert extra information into one of these. It's for tracking for other purpose, right? It really shouldn't be done. It's not the best practice, but it does happen. But you have to assume when you see these and doing, your risk assessment, or if you're watching your, TPRM, you're scanning your software as you put it out in every update. When you see this, you have to assume it's tampering. You have to assume it's an attack, and you have to stop. That's it. Now you pass this on to your investigation teams or you kick off whatever process you have, but you have to assume there's something wrong with this software. You don't install it, and you have to go back and make sure it wasn't installed anywhere. Use your EDR tools to remove this, do whatever you have to do, but you have to treat it like an attack. You can't be so concerned that, it could be this, it could be that. No, you have to just assume, it's bad and treat it that way until someone proves to you it's not, right? And this is the piece that's so important about software risk assessments and doing TPRM. It doesn't matter if you're wrong, right? There's no way that it hurts you to hold this back for a couple of weeks until you get an answer from a vendor, or wait to see, like 3CX, right? If this doesn't look right, you don't push it out. It would have taken another week before all of a sudden you saw it was an attack. So delaying it doesn't hurt you one bit. If you're suspicious about something, you don't like something that doesn't look weird, you don't understand something, by all means, don't push it out, stop, kick off your investigation process, kick it to whatever team can do that, or contact the vendor. Don't be afraid to say no. Revoked certificates, again, this is something that you want to be really concerned about when you see it in your software. Again, we talked about these certificates. It's all about trust. It's all about validating the trust and having a chain where each chain validates the piece below it. If that's broken in anywhere, then you have to assume compromise. there could be other way. This is almost always a sign of tampering or a cert was stolen or abused or whatever. Because the system is based on trust, it reacts very quickly when that trust is broken. So again, this is full stop. You have an incident. Don't push the package, kick off whatever your process is. But you can't be afraid to do that. You can't be afraid to pull that trigger and say, hey, this doesn't look right. And I don't know why it doesn't look right, but I'm not going to okay this thing. That's part of the job. So on the counter on that is there are mitigations that can be built into the code that we do see people use a lot, right? It's not used for every certificate. It's not used for every package or third-party element that you have in here, but it should be used. And if you do see that, it should give you comfort because they're building in a mitigation to ensure that. So like we said, these certificates have a lifespan, 18 months, let's say. At the end of that, it's no good. You have to get another one, right? Because you're reestablishing that trust. This is a way to check that much more quickly. So you'll see, traffic in your package, right? If you have a tool that it does static analysis and will tell you all these things, tell you what traffic it can generate, what URLs are embedded in the software, what it might contact, that kind of thing. You hope to see any domains that are OCSP dot whatever or CRL dot whatever. Those are the two mitigation elements. That's a live way to go check and see the most updated list of revoked certificates and ensure that the ones you're using aren't. If you see that, that means that this best practice is in place. And if it's a vendor code, that they're taking this stuff seriously and they're ensuring that there's less of a chance that you can get hit with an abused certificate. So that's a good thing. That should figure into your assessment, right? Is this, they're doing the right thing. And the more of this you see, the more comfortable you can be that that vendor is also taking care of the other little things that matter to you to make secure software that lowers your risk. So it's looking at, all of these things through a different lens, right? You can make assumptions and get details off of how these things are used and how they show up in your programs. And that's what we need to do. Everything about software supply chain is like this. It's, familiar elements that you've seen before, you've heard about, you've used before, but not in this context, not in this way. So all of these things you have to look through a fresh lens. We also do see extended validation code signing certificates occasionally. I wish we'd see more of these, but this is an extra step that vendors can take. And we do detect these and we'll have an alert to tell you whether this is in the package or not, which is good, right? Because we want to show you the positive too, not just the negative, because that's part of your assessment. You weigh the good and the bad, how that impacts you, and then you make a decision. So extended validation is just a deeper vetting process again, it's extra trust. It's like going to a notary. Right. That's the whole point of a notary is a third party is validating your stuff and your driver's license or whatever to say you are who you say you are. It's the same kind of thing with these certificate authorities. They do it, but then this is this extended step. It does cost more. There's an extra charge for this, and it does take longer for that vetting. So it doesn't get used all the time. But if you do see this, that tells you something about that vendor, that they do take this stuff seriously and they're trying to protect their code and their customers. So this should figure into your scoring as well. So, there's a lot of depth to this, and really we could talk about this for hours, but the goal is to just get you comfortable with, I can make assessments based on these. I can do things with this information, and it should inform my risk assessment. So hopefully this, made a lot of sense. You sort of get the gist of this, and then you can do your own research and look things up as you find these near packages. As you're using these tools and things come up, you do a little bit of research, but, if you're not sure, say no. So that was really the overview. We want to do it quick. We want to keep it service level and just get you thinking differently about some of these common elements that you may not realize the value they have. Anybody has any questions, comments, please, shout them out, throw them in the QA, and I'm happy to address them.
Okay, well, while we're waiting for any questions to come in, we can just move on to the next slide. All right, so for those of you that are interested in analyzing your own software supply chain security profile, we've got a 14-day free trial available to you of the same software that Tim used to fine-tune a risk assessment policy baseline around code signing certificates. And I'm going to go ahead and put the link to that right here in the chat for everyone. So it's available at that link, and there's no credit card required or software to install. Just create an account and you'll get 14 days of free access to a full-blown version of our software supply chain security platform. You can use it to analyze malware and code tampering embedded in your software components, or generate an SBOM listing, all open source on third-party packages and software you're using, or leverage the platform to contextualize and prioritize alerts and threats in your software supply chain. Again, there's no charge, so please take advantage of this risk-free trial. Next slide. We have some great webinars coming up the rest of the month. You may want to check them out. And to learn more about our lineup for August, just visit the link that I'm putting into the chat. Oh, somebody beat me to it. And at that link, you can view all the upcoming webinars. And of course, Reversing Labs will be at Black Hat, B-Sides Las Vegas, and DEF CON 31. And we'd love to see you there if you're going. So come visit us and stop by the Reversing Labs booth, number 3034. There'll be demos, there'll be some cool free swag, and there'll be a great opportunity to meet some industry-leading authors. And you can learn more on our Hacker Summer Camp webpage with the link that's about to pop into your chat again. And there it is. Okay, next slide. And that concludes this episode of Software Package Deconstruction. Thank you all again for attending. Please be on the lookout for announcements about future episodes from Reversing Labs. Have a great rest of the day, everyone, as well as a great rest of the week. And remember to broaden your view of software risk by securing your entire software supply chain.